the welding department at BCIT, building NE8. And the welding department teaches the curriculum set out from the Industry Training Authority, all levels of the apprenticeship system for welding. We just finished a welding ventilation upgrade, which has not only created a great working environment for our teachers, but an excellent learning environment for our students. By consulting with engineers, manufacturers, including other facilities, I feel we've built the most energy efficient and economically practical ventilation system possible. We've set a new standard. This is an on-demand system which only extracts fumes or heat from the building when a student is welding. It's a variable speed drive system which only ramps up or uses more energy when more students are welding. We have a result. The result is that it's cleaner air and it uses far less energy to operate and heat this building. It's a rare combination, a construction trade such as welding and a sustainable and environmentally sound initiative coming together. The result? Clean air and a reduction in greenhouse gases by reduced energy consumption. We're now going to talk to Richard Cora from Rocky Point Engineering, who designed the system.
The building had an existing ventilation system that was very inefficient. Essentially, it ran for 16 hours a day. The exhaust turned on, the makeup air unit turned on, and there really was no way to shut it off. It just ran all day long, and the idea was to introduce a demand control ventilation system. The welding booths themselves are not always occupied, and so the idea of the system is to only turn on the exhaust when a student is actually in the booth. So what we're going to look at today is the ventilation and exhaust system installed at BCIT, which is a variable flow makeup air and exhaust system. The way the exhaust system works is, as a student enters the booth, an occupancy sensor picks up their occupancy, and then a motorized damper, that blue device up there, essentially opens. And as each booth is occupied, each damper opens. As the dampers open, pressure is detected in the ductwork, and a variable speed drive increases the speed of the exhaust fan. Now, at the same time as the exhaust is changing air volume, the makeup air has to match that volume. So there's a airflow measuring station in the exhaust system and an airflow measuring station in the supply system. And both of those are synchronized so that we get the correct supply volume and correct exhaust volume. The result is that as the fan speeds are changing up and down, we get a high level of energy performance due to the savings in fan horsepower and makeup air requirements as well. Okay, well, in addition to the variable flow exhaust that we've talked about, the welding booths also have continuous exhaust. And essentially what we do is we provide continuous exhaust at the hood and variable flow exhaust at the welding arm. Now, in order to maintain that continuous exhaust at the hood, you can imagine that as all the dampers are opening and closing, the velocity in the ductwork is changing quite erratically. And the way that we maintain constant flow to all the exhaust hoods is with a pressure-independent VAV box up here. And what that box does is, as the flow is changing, it automatically adjusts the airflow to maintain the correct volume at all the exhaust hoods.
Each booth is individually controlled by either a motion sensor or an arc sensor. The snorkel is our main source capture. We can move this where the welding is being done between 6 to 8 inches away to extract the fumes that are being created. The secondary source capture is this exhaust hood up here. So there's less CFM running through here, but there's about 600 running through the exhaust hoods. So this is only activated when you're in the booth moving around, because we have a motion sensor up here in the back corner. Out of the 96 arc welding booths, 80 of them have an arc sensor. You'll see here that we have a control panel up here. It goes to a clamp that clamps onto the welding circuit. As we put it onto the welding cable, currently the system has an open circuit. Once you strike the arc and start welding, it's a closed circuit. What happens is that it opens up the auto dampeners, which allow ventilation to come through the snorkel as you're welding. It has a timer on it. Once it times out and you stop welding, it'll run for about 2 minutes, and then it'll turn off.
Okay, we're here looking at a typical variable frequency drive. This device is what's used to vary the speed of the fan. Essentially what it does is it takes AC synchronous current at 60 Hertz, converts it to DC, and then back to AC, but at a different frequency, anywhere from 0 to 60 Hertz. So if you want to run the fan at 50% speed, you're essentially creating 30 Hertz electricity to an AC synchronous motor. So that's how we achieve variable speed on both the supply and exhaust. Well, we're up here on the roof to take a look at the variable flow exhaust and makeup air systems. And beside me here is the variable flow welding exhaust, which consists of the ductwork coming up from below, an inlet silencer, motorized damper, the fan, and a variable speed drive in a weatherproof enclosure similar to the one we saw downstairs. On the discharge side of the fan, there's an exhaust stack which discharges the welding fumes well above the roof of the building. Okay, the other piece of equipment up on the roof that we wanted to point out to you today is the gas-fired makeup air unit. It's a high-efficiency gas-fired makeup air unit that also has variable speed control on the fan that's synchronized to the exhaust system. So as the exhaust system that we've been looking at speeds up and down, so does the makeup air unit. I've got one of the doors open so that we can look inside to see the inlet dampers and filter section on the air handling unit. And this unit is special because in the future, what we've built into this unit is space to connect to BCIT's future district heating system and infrastructure to use reclaimed heat to heat makeup air in the building. Right now we're using gas, but in the future we could essentially use other energy sources when it becomes available. Okay, we've opened up the gas-fired section of the makeup air unit to take a look at the gas-fired burner. And what you see is the modulating burner itself, which controls the amount of air going into the combustion chamber, and the modulating gas valves, which automatically adjust for the amount of gas depending on the heat output required for controlling the discharge air temperature and the speed of the supply fan. So this is where all of the majority of the gas savings are achieved at the modulating gas burner on the makeup air unit. Well, we're now taking a look at the grinding room ventilation system, which uses a demand-controlled dust collection system. Now, the way that this system works, which is similar to the welding booth, which you remember used an occupancy sensor, what we do in the grinding room is we actually have a pressure-sensitive pad. When the student walks into the grinding area, they step on the pad. As soon as they step on the pad, the controller picks up their contact and opens a motorized damper to turn on the exhaust system at this particular grinding station. So again, demand control ventilation, variable speed control, energy efficiency.
So now with this new ventilation system, it's increased everybody's spirits around here. They feel a lot more healthy and people are happier working in this work environment. It's not only an economical savings, but it's also a case of health and safety, which contributes to a better work environment for everyone.